Scientists really did point some of the most sensitive radio telescopes on the planet at the interstellar object 3I/Atlas and scan it for a signal. That part is completely true. What often gets left out is the actual result, and it's worth being upfront about it right away because the honest version of this story is genuinely more interesting than the mysterious version. Stick around, because I'm going to walk you through exactly what researchers were listening for, what their instruments actually detected, and why an investigation that turned up nothing artificial still represents one of the most important searches ever conducted on an object like this. And if you want more of these deep dives into real published research instead of recycled headlines, go ahead and subscribe now, because there's a lot more coming out of the far edges of our solar system. To understand why anyone bothered pointing a radio telescope at a comet in the first place, you first need to understand what makes 3I/Atlas different from literally everything else astronomers study. It's an interstellar object, meaning it didn't form here. It formed around some other star, drifted through the emptiness between stars for potentially billions of years, and then, purely by chance, its path carried it through our solar system. Discovered on July 1st of 2025 by the Atlas Survey Telescope Network, it became only the third such object ever confirmed in recorded astronomical history, after Oumuamua in 2017 and Borisov in 2019. Objects this rare, arriving from somewhere else in the galaxy entirely, are precisely the kind of target that makes scientists want to check every possible angle, including one that sounds more like science fiction than mainstream astronomy, whether it might not be natural at all. That's not as far-fetched a question as it might initially sound. And it's worth explaining why researchers take it seriously rather than dismissing it outright. Scientists have long discussed the theoretical possibility that an advanced civilization elsewhere in the galaxy could send out interstellar probes, and that if such a thing existed, it might eventually pass through another star system, including ours, behaving in ways that look almost identical to a natural comet from a distance. Researchers sometimes call the search for this kind of evidence a technosignature search, essentially looking for any sign of engineered technology rather than naturally occurring phenomena. Given that only 3 interstellar objects have ever been confirmed passing through our solar system, and given that each one represents an exceptionally rare opportunity to check, several research teams decided this was exactly the kind of situation where a thorough radio search was scientifically warranted, regardless of how likely or unlikely the outcome seemed going in. This line of thinking traces back further than 3I/Atlas itself, and it's worth understanding that history briefly, because it shapes exactly how seriously researchers treat every new interstellar visitor that comes along. Back in 1985, researchers Robert Freitas and Francisco Valdés published an early theoretical paper specifically examining the plausibility of interstellar probes as a detectable form of extraterrestrial technology, well before anyone had ever actually confirmed a real interstellar object passing through our solar system to test the idea against. That paper, along with decades of subsequent theoretical work on the broader question, established technosignature searches on interstellar objects as a legitimate, if narrow, subfield of astronomy long before Oumuamua ever gave researchers their first real opportunity to actually attempt one. When 3I/Atlas arrived in 2025, it represented only the third genuine chance in recorded history to put that decades-old theoretical framework into practice against a real target. If you're finding this as fascinating as the researchers involved clearly do, drop a comment and let me know, because it genuinely helps me figure out what other space stories are worth covering next. The most detailed of these searches was carried out by a team at the SETI Institute, led by astronomer Sophia Sheikh, using an instrument called the Allen Telescope Array, a network of 42 coordinated radio dishes located at the Hat Creek Radio Observatory in Northern California. The team pointed the array at 3I/Atlas within just days of its discovery in early July of 2025, scanning across a wide range of radio frequencies between roughly 1 and 9 gigahertz, specifically searching for any narrow, artificial-looking radio emission that couldn't be explained by natural astrophysical processes. Their results, published in June of 2026 in the Astronomical Journal, were unambiguous. According to the paper, every single candidate signal detected during the observation could be traced directly back to ordinary terrestrial or satellite interference, radio noise generated right here on or near Earth, rather than anything coming from the comet itself. The search set a firm upper limit on any possible radio transmission from the object, ruling out any technological signals stronger than somewhere between 10 and 110 watts of effective power across that entire frequency range. An extremely sensitive threshold that would have caught even a fairly modest artificial transmitter if one had actually been present. The SETI Institute's search wasn't the only one conducted, and it's worth understanding just how thorough this overall investigation actually was. The Breakthrough Listen initiative, a separate, well-funded techno-signature research program, coordinated its own set of observations using multiple different radio facilities around the world, beginning shortly after the comet's discovery and continuing all the way through its closest approach to Earth in December of 2025. That included additional time on the Allen Telescope Array itself, as well as observations using the Meerkat Array in South Africa, one of the most powerful radio telescope networks currently operating anywhere in the world. According to Breakthrough Listen's own published summary of the results, no techno-signatures were detected in any of these searches, across every facility and every observing window they used. There is one genuinely interesting radio detection that came out of this broader observing campaign, and it's worth explaining clearly, because it illustrates the difference between an artificial signal and a completely natural one that simply happens to show up on a radio telescope. The Meerkat Array detected a specific spectral signature associated with hydroxyl, a molecule made of one oxygen and one hydrogen atom bonded together. That detection wasn't remotely mysterious to the researchers involved. Hydroxyl is exactly what you'd expect to find when sunlight breaks apart water ice on a comet's surface, a completely ordinary, well-understood byproduct of normal cometary activity, the same basic process responsible for the visible coma and tail that comets have always displayed. Detecting hydroxyl was, if anything, further confirmation that 3I/Atlas was behaving exactly like the icy, sun-warmed natural object researchers already believed it to be, not a hint of anything artificial. It's worth being direct about where this fits into the broader public conversation surrounding 3I/Atlas because the object has genuinely generated real scientific debate, just not over whether it emitted a radio signal. Harvard astrophysicist Avi Loeb has spent months publishing detailed analyses arguing that several other features of the comet, an unusual glow pointing toward the sun instead of away from it, a small but measurable acceleration in its trajectory that doesn't perfectly match simple outgassing models, and its overall chemistry deserve closer scrutiny before anyone declares the case fully closed, and he has been open about not ruling out more exotic explanations. It's important to be clear that this radio search doesn't really engage with those specific arguments one way or the other, since Loeb's proposed scenarios generally don't require an active radio transmitter to be broadcasting from the object in order to be considered. What the SETI Institute and Breakthrough Listen searches specifically tested was the narrower, more direct question of whether 3I/Atlas might be actively emitting any kind of engineered radio signal. And on that specific question, the answer came back clean and consistent across every instrument that looked. According to Valeria Garcia Lopez, an astronomer with Furman University and a Breakthrough Listen collaborator involved in this research, the value of this kind of search isn't really about expecting to find something. It's about establishing that finding something would actually be possible with today's technology if it were there. She's noted publicly that these results demonstrate just how realistic it genuinely is to detect a signal using current instruments, which is precisely why continuing to search, even on objects researchers don't expect to show anything unusual, remains scientifically worthwhile. In other words, a clean, thorough non-detection isn't a wasted effort, it's a calibration. Proof that if an interstellar visitor really were broadcasting, our current instruments stand a real chance of catching it. And that confidence only comes from actually running the test on genuine real-world targets like this one rather than simply assuming the answer in advance. There's a broader scientific context worth understanding here too, because this radio search was only one small piece of an extraordinarily large, coordinated observational effort aimed at 3I/Atlas throughout its passage through our solar system. According to tracking compiled by researchers following the mission, a genuinely remarkable fleet of spacecraft and telescopes contributed observations of this single object, including the Hubble and James Webb Space Telescopes, NASA's Mars Reconnaissance Orbiter and Perseverance rover, the Psyche spacecraft, and the European Space Agency's Mars Express and JUICE missions, among numerous others. That level of coordinated multi-instrument attention is genuinely rare for any single object, and it reflects just how seriously the scientific community treated this specific opportunity, checking every available line of evidence, chemical composition, trajectory, radio emissions, and more rather than relying on any single measurement to settle the question of what this object actually was. It's worth appreciating just how logistically complicated that kind of coordinated campaign actually is, because spacecraft, like the ones involved here, were never designed with interstellar object observation as their primary mission. Mars Reconnaissance Orbiter and Perseverance were built to study the Martian surface and atmosphere, not to track a small, fast-moving comet passing millions of miles away. Repurposing instruments like these for even brief observation windows required mission teams to carefully weigh the scientific value against the operational cost of diverting a spacecraft's attention, however briefly, away from its primary assignment. But so many independent missions Considered within the broader planetary science community, an opportunity worth this much coordinated effort, specifically because objects like 3I/Atlas pass through only once, on a trajectory that guarantees they'll never return for a second look. Taken together, that broader body of evidence has continued pointing toward a consistent, if genuinely unusual, natural explanation. Spectroscopic observations from Webb identified the comet's coma as unusually rich in carbon dioxide, along with water, carbon monoxide, and methane, an unusual but chemically coherent mixture entirely consistent with an old natural comet, rather than anything resembling propulsion exhaust or manufactured material. Isotope measurements taken from that same data suggested the object may have formed somewhere between 10 and 12 billion years ago, potentially older than our own sun, a finding independently supported by a separate trajectory analysis tracing the comet's path back to an ancient region of the Milky Way called the thick disk. None of that evidence is remotely consistent with anything artificial. If anything, it paints a picture of an object that's almost the opposite of mysterious in the conventional sense. An extraordinarily old, well-preserved natural time capsule, rather than a hidden alien mystery. So what does all of this actually add up to? Scientists really did investigate 3I/Atlas for something resembling a signal using some of the most capable radio telescopes on the planet across multiple independent research programs, spanning months of observation from the moment it was discovered through its closest approach to Earth. And the honest, fully documented result of that investigation is silence. A clean, consistent non-detection across every facility and every frequency range tested, with the only actual signals traced back to ordinary human radio interference, or, in one case, the completely natural chemical signature of sunlight breaking apart cometary ice. That's worth sitting with for a moment, because it says something genuinely useful about how to read headlines like the one that likely brought you to this video in the first place. A story built around scientists investigating a mysterious signal is technically accurate, in the narrow sense that an investigation genuinely happened. But leaving out the actual outcome of that investigation turns a real, carefully documented piece of science into something closer to a cliffhanger with no resolution. When the resolution was published, peer-reviewed, and publicly available the entire time. That's not a less interesting story than a mysterious transmission would have been. It's a genuinely valuable piece of science in its own right, proof that when a real opportunity like this comes along, researchers have both the tools and the willingness to check thoroughly, rather than simply assuming an answer either way. If stories like this one, grounded in real published research and honest about what was actually found, are what you want more of, subscribe to this channel and turn on notifications, because there's a real chance the next interstellar visitor gets the exact same careful, thorough scrutiny this one just received. Thanks for watching, and I'll see you in the next one.